Alright, let's get it. So we have a cubic function, x cubed minus 6x squared plus kx minus 5, that has a turning point at x equals 3. So cubic, since the coefficient of the x cubed term is positive, we know it is a positive cubic. We know one of the turning points is at x equals 3, so that could be the maximum or the minimum. We're not too sure yet. Use calculus methods to find the coordinates of both turning points. Alright, well, we know the x value of one turning point. So if we could find the y value, we're halfway there. However, you'll notice the original function has this unknown parameter k, right? Some constant. So we're going to need to find that. Because once we have it, we could just graph the cubic and we know what it looks like. Cool. Alright, and finally, just justifying our answer as to why one is a maximum or minimum. So let's write a plan out first. So step 1, we need to find k. Now to do that, the only information we're really given is this bit here. So turning point. So the gradient of a turning point is 0. And we know that's one of them is at x equals 3. So to find k, we need to find the derivative, dy by dx, and then use this information that the derivative is 0 when x equals 3. Yep. So in doing so, we would have an equation with the only unknown being k. So then we get k. Cool. Step 2 is we need to find the x values of the turning points. Now, you'll notice we're already given 1 at x equals 3, so that's great, but we do need to find the other one. And to do that, we would set the derivative equal to 0 and solve for x. And we would expect one of them to be x equals 3. Okay, and with our x values, we can then find the y values of the min or max points, or I should say turning points, keep it consistent. And to do that, we will use our original function, keeping in mind we found k, so now it's complete. So using y equals x cubed dot dot dot. Now once we have those, we will then justify which is max or min. And if you have the y values, it's very easy, because the turning point with a larger y value is the maximum. The turning point with a lower y value is the minimum. Cool, so there's our plan. So let's get to it. So step 1, find k. To do that, we need to find the derivative. So dy by dx. So the derivative of this function here would be 3x squared. So again, taking the 3, multiplying it out the front, and then subtracting 1 from the power. Similarly, 2 times minus 6 gives minus 12. Subtract 1 from the power gives us x to the power of 1, plus kx. So the derivative of any constant times x is that constant, or in this case the constant is k. The derivative of minus 5, the derivative of a constant is 0. So we don't need to write that. Alright, so we found the derivative. We now need to set the derivative equal to 0 when x equals 3 to find k. Right, and why we are doing that is we were told that there is a turning point, in other words, the gradient is 0, when x equals 3. So we set the gradient to 0, in for x goes 3, and you'll see we're left with one equation, and the only unknown is k. So let's solve for that. So we have 9 minus 36, or we add 36 to both sides and then subtract 9, that's k equals 27. I think. Is that right? Do that again. Oh, no. Right, this is why you write out your steps or use your calculator. So 3 squared is 9. 9 times 3 is 27. There we go. Now that is minus 9, so k equals 9. Whew, good save. So k equals minus 9. Alright, so we did step 1. Go us. Now we need to find the x values of the turning points. Again, we already know one of them, but we need to find the other. So to find the x values of the turning points, we set the derivative equal to 0. Right? Except this time, we now know k. So to 0, we equate 3x squared minus 12x plus k, where k is 9. And you'll see we have a quadratic equation, which we can solve. I see that 3 is a common factor in every term, so I will divide everything by 3. And then on the right hand side, it looks like we have some nice numbers, so we can factorize. So two numbers that multiply to positive 3 and add to negative 4. So x minus 3 and x minus 1. Which means if we're to solve for it, either x minus 3 equals 0 or x minus 1 equals 0. Which means x would equal 3 or x would equal 1. Now let's double check. So there's a turning point at 3. That's great. But there's also one at x equals 1. So we know that this point is at x equals 1 and this point is at x equals 3. All good, done that. Now, just actually looking at our sketch, since we know it's a positive cubic, we know that the turning point with a lower x value, in this case x equals 1, will actually correspond to the maximum, right? Just by the shape of the graph. Cool. Now part 3, find the y values. So that's substituting our x values into the original formula to find the y values. X cubed minus 6x squared plus kx minus 5. And we found k was actually 9, so we can substitute that in. Cool. So for x equals 1, y would equal 1 cubed minus 6 times 1 squared plus 9 times 1 minus 5. Which would be 1 minus 6 plus 9. Minus 5 plus 9 would be 4. Which gives us the point at x equals 1, y equals 4. I think. Or is my maths wrong? My maths feels wrong. 1 minus 6 minus 5. Oh, I forgot to minus 5. Good thing I double checked. So that would be minus 1. So we have a turning point at 1 minus 1. Alright, now let's check for x equals 3. Y would be 3 cubed minus 6 times 3 squared plus 9 times 3 minus 5. So what's that? 27. 9 times 6 minus 54 plus 27 minus 5, which would give minus 5. So there's a point at x equals 3, y equals minus 5. Great, so we found the y values. And we wrote them as a coordinate, right, an xy pair. Now we need to justify which is the max or which is the minimum. Alright, so the obvious way to do it, there is a maximum at 1, negative 1 as its y value is greater than the minimum at 3, negative 5. And that would be sufficient, right? We just compared this y value to that y value. And since negative 1 is greater than negative 5, it must be the maximum. Alternatively, we could mention that since it's a positive cubic, the maximum corresponds to the turning point with the lower x value. Right? The maximum comes first before the minimum, right? Reading left to right. Also perfectly fine. Alright, so let's quickly go over that question one more time. Forgot to put my green circle in. So firstly, we acknowledged it was a positive cubic with this constant k that was missing. So we had to solve for that first by using the turning point information. And to access that, we needed to find the derivative, right? And actually doing that, finding the derivative and then finding k would be the sort of achieved and merit points. So achieved and merit was then finding the x values of the turning points. Using those x values, we were able to find the y values of the turning points and then justify which one was a minimum and which one was a maximum. Now what you should definitely do if you have time at the end of your exam is graph it. So in menu graph, you should graph this equation and solve for the min and max using gsolve to make sure your answer lines up. Alright, and then give yourself a tick, save your marker some time. Okay, don't actually do that, but you know. Alright.